Okay, let's give you guys some more practice. Let's just say you've been given a speed time graph for, let's say, a car. So this is a speed time graph for, let's say, a car. At time equals 2, at time equals 2, and at time equals, let's just say 7. At time equals 7 here, which of these two times is a car going fastest? At time equals 2 or at time equals 7? Okay, so yeah, so press pause and have a go. Which of the two times is a car going fastest? So well, you've been given a speed time graph, and I'm asking. So you've been given this graph here, and this is a speed time graph, and I'm asking you about the speed. You've been given the speed time graph, and I'm asking you about the speed. So it's really a straight reading. So here the speed is 2, and here the speed is at 4. So of course the speed at time equals 7 is higher than the speed at time equals 2. So the answer to this question is that it's going faster at time equals 7 than it is at time equals 2. Okay? So anyway, the next one here, given the distance time graph, let's say for a car, so at time equals 2 and at time equals 7 here, which of the two times is a car going fastest? Okay, so press pause and have a go. Okay, so this one here, visualize the three graphs in your mind. You've got your speed time graph here, and you've got your distance time graph. You've been given the distance time graph, so you've been given this graph here. Now you're being asked about the speed. So when given a distance time graph, if you want to know the speed, then you've got to consider the gradient. So the speed at time equals 2 would be the gradient here, and the speed at time equals 7 would be the gradient here. So it boils down to which is the steepest gradient, because the gradient or the distance time graph represents the speed. So the gradient here would represent the speed. So the gradient here, the up and down here is 2, and the across here is 3. So the speed at time equals 2 is given by this. Now the speed at time equals 7, the speed here would be the gradient here, 3 over 2. Okay, so this here, well, you can see that this here is bigger than this. So the speed here at the speed at time equals 7 here is 3 over 2. The speed at time equals 2 here is well, it's going faster at t equals 7. Okay, so next one here. Given this speed time graph here, let's say at time equals 2 and at time equals, let's say, 7 here. Which of these two times is a car going fastest? Okay, so press pause and have a go. Okay, you've been given the speed time graph. You've been given the speed time graph, and you're being asked about the speed. So at time equals 2 and at time equals 7 here. You've been given the speed time graph, and you're being asked about the speed. So it's really a straight reading. The speed here is 1 point something. The speed here is 3 point something. So it's going fastest at t equals 7 as opposed to t equals 2. So it's going faster here. Okay, at time equals 7. Okay, next one here. Given this distance time graph for let's say a car, which of these two times is it going fastest? Okay, at time equals 2 or at time equals 7. So press pause and have a go. So remember when given a distance time graph, the gradient represents the speed. So the gradient here is 0. So the speed here is 0. The gradient here is also 0. So while the car is stationary, the answer to this question is they're both the same. They're going at the same speed, and the speed is actually 0. The car is stationary all the way through. So the speed here is 0. The speed here is 0. Okay.